Right, let's continue part 2. Now, this is question 4. I'm not going to do this. You are going to do it yourself. I'll give you the answer. So, try it out on your own. The answer is mass of zinc is 0.325 grams. Okay? Right. Try to do it yourself. See if you can get this answer. So we will leave this for you to do it on your own. Now we are going to the next part. The next part is calculating volumes of reacting gases. The keyword here is now, what we are going to learn here applies only to gases. Okay, so 1 mole of any gas occupies 24 dm cube. We already learned that. And what happens is that equal volumes of all gases will contain the same number of particles. Okay, that means that, okay, cut a long story short, we will talk about the fact that the mole ratio, remember we've been talking about mole ratio in the calculation. Mole ratio, if it is a gas, will be equal to the volume ratio of the gas. So we just need to learn this important key point, which is that for gases, the mole ratio is equal to the volume ratio. How do we use this in a question? So let's further explain this. Now, if we have this reaction, 2 moles of NO, right? This is the 2 here telling us that there are 2 moles. 1 mole of oxygen, because there's no number written in front means 1. And there are 2 moles of NO2. Now, this is in terms of mole. It will also apply to volume, the same number. 2 moles, you can also change it to 2 volumes. And 1 volume. And 2 volumes. So mole ratio, this is our mole ratio. It is the same as or equal to the volume ratio if all the substances we are talking about are gases. Let's look at the first example. Now, again, let's underline the information that we are given. Any number, any numerical value, that's important. So we are told that 20 dm cube of ethene was burnt. What do we want to calculate? We want to calculate two things: the volume of oxygen and the volume of carbon dioxide. Okay, and all of them are gases. So that's the important point. We can only apply this method if they are all gases. So now let's write out the mole ratio. So mole ratio will be equals to 1:3:2:2. Actually, this one cannot use because this is not a gas. All right, this is not a gas, so it doesn't apply. Okay. But then we already learned that mole ratio is equals to volume ratio. So we will represent it as V. All right, 1 mole now will be equals to 1 volume, 3 volume, 2 volumes. Okay. Now, what are we given? From the information, we are given 20 dm cube of ethene, right? 20 dm cube. So given that 1V, now we equate this. 1V is equals to 20, correct? 1V is equals to 20. Oxygen will be 3V. How much will oxygen be? So it's just 1V is 20, 3V will be 3 times 20. And already we get the answer, 60 dm cube. And how much is carbon dioxide? 2V, which will be 2 times 20, which will be 40 dm cube. Simple, very easy. No need to go through MRU, no need to look at periodic table to find AR or MR. Just simple mole ratio equals to volume ratio. Okay, let's try. Now let's try equation. Let's try a question. ethene reacts with oxygen according to blah, blah, blah. Now, what information are we given? So, information given, 80 dm cube, correct? 80 dm cube of carbon dioxide. That's what we're given. So, and of course, the other thing is they are all gases, right? They are all gases. So water is a liquid, so you cannot talk about water. You cannot calculate for water. Find, what we asked to find, volume of ethane. So which one is ethane? Ethane is the C2H6. This is our unknown. All right? So let's write out the first step, mole ratio. So mole ratio is 2C2H6 is to 7O2 is to 4CO2. The mole ratio is 2 mole is to 7 mole is to 4 moles based on the balancing numbers. Now we say that mole ratio is equals to volume ratio, and we represent volume as V. So this will be 2V is to 7V is to 4V. Agree? Right. Now, what are given? What's given? So we are given that carbon dioxide is 80 cm cube. So we are given that carbon dioxide here is 80 cm cube. So how much will ethane be? And how much will oxygen be? So A, volume of ethane is how much? So 4V is 80, 1V must be, 1V is 20. Agreed? So from here, right, 4V equals to 80 cm cube. V must be equals to 20 cm cube. Therefore, volume of ethane will be, ethane is 2V, which is 2 times 20 cm cube. Is that okay? Right, next one, volume of oxygen. So volume of oxygen will be equals to, oxygen is 7V. So 7 times 20. And this will be 140 cm cube. So much easier to do, right? So if you see a question where it's all gases, use this method. It's a lot easier than the MRU. Okay? Next question. Let's try. Okay, you all try this. Right, try this yourself. Pause the video, try it yourself. I give you a hint. First step, write out the mole ratio. Okay, pause the video, try it out yourself. So, mole ratio will be equals to N2 is to 2H2 because we are given hydrogen. So hydrogen is this one. And what volume of nitrogen? Nitrogen is this one. Okay, so we know that we have to take the ratio of these two things. Substitute in the 500 dm cube. So here will be 500 dm cube. Oh, sorry, wait. We have not talked about volume. So, mole ratio equals to volume ratio. So this will be 1V is to 2V. Okay? Now put in the 500 dm cube. So here is 500 dm cube. How much was this? So from here, we know that 2V equals to 500. V will be equals to 250. Therefore, volume of nitrogen will be equals to 1V. 1V, which will be 1 times 250 dm cube. Is that okay? And that's already the answer. Okay. Now, next part. Now, this part is very difficult. It's called volumetric analysis, and it involves a method called titration. Okay, I tell you what, I will stop here. I will do a separate video on this because this is a difficult one by itself. We'll stop here for now.